Hey guys, so in this video we'll see how to code SR flip-flop in VHDL language. So first of all we'll see what is the SR flip-flop is. Okay, so this is the basic circuit of SR flip-flop, and we get a truth table of SR flip-flop in which we see that when set and reset. So now we'll just see this in our VHDL program. So we'll open EDA playground and okay, from we'll choose the VHDL from here and select the simulator, that is this one. And okay, I have already written the code and I'll just copy paste it for you. Paste. Oops. Copy and paste. Okay, so in this code, first of all, these files are the library files which includes the predefined functions these such as this if and entity architecture, these all things. This is the package file, and this is the entity, and this is how we have declared the entity. This is the name of the entity. We can give any name according to our choice. And so these are the port that is S and R, that is in standard logic, which is the input lines. We can just predict here. Okay, this is S and this is R, and these are the input lines. So this is the basic syntax to write it as input. Okay, so this is clock given as input, and Q bar as a out standard logic. We can see Q bar as out standard logic. Okay, so we'll end the srff, and the entity, which is the entity, will end here. And now architecture is the process which is going on between here. Okay, so in this we have to write the architecture. We have to give the name of the architecture, that is BHEV. You can give whatever you want, it's up to you. And then off, this is syntax, and srff is the entity name. Okay, and is so begin syntax. And process, in process we have to just input the values that we are using as a that we are giving the values in here architecture. Okay, only that values we have to put here in process. And begin, and then if clock and clock event. Okay, uh, after begin, if statement will work. If this is if statement is true, then this if statement will work. Okay, sorry, if this if statement is true, then this if statement will work. Else if this is wrong, then this will work. Okay, and the process continues. Okay, what is clock and clock event? It means when the clock is high and it will be at a rising edge, clock equal to 1, and clock event means that it will at rising edge and it will be high. At that time the processes under this if should work. Okay, now if we have given if s equal to 0, r equal to 0, then it is a memory state, so we are just passing the q and q bar into its respective q and q bar only. Okay, if this condition is not true, that means if else if s equal to 0 or r equal to 1, then we have to give q equal to 0 and q bar equal to 1. Okay, if this is also not true, if it is s equal to 1 and r equal to 0, then q will get 1 and q bar will get 0. Else if both are 1, s equal to 1 and r is equal to 1, then q and q bar will get the invalid statement. For invalid statement, we put z. It's in the syntax, it's in the language process, we have to put z here for undefined values. Okay, so we are ending this if here, and then ending this if for this all, and then end process, and then end behavioral, that is ending the architecture. Okay, so this code, VHDL code for the SR flip-flop is complete. So we have to give one more, we have to see one more code, which is a test bench code. In this we anyways provide the only inputs, what input we are giving all. Okay, so basically first of all it's the same library files, then test entity declaration, same as this. Okay, but we haven't declared the entity here. Okay, we have given the name of the entity test bench, and we have entered the entity. Okay, then we have the given architecture name as the test data of test bench is. Okay, we have defined the signals here in the architecture, signals, and the signals which we are mapping here. We have to also define the component like SR, clock, and Q1, Q bar. Okay, so first of all we have to define these signals, that S and R. You can give any name you want, but it make sure that these are in proper sequence. Okay, if you're giving S here, then S here, R and R, clock and clock, Q and Q bar. Okay, you have to define the component, and you have to map these signals. You have to map these signals with the component values. Okay, component is basically the entity declaration only. You have to just map with the signals, and just a name. You can give anything. Okay, process begin. Then for we have just applied the for loop for the clock pulses, okay, at first 10 nanosecond it will be 0, and after 10 nanosecond it will be 1, and it will be continue to the 5 loops. Okay, so uh, then we have just given the values to S and R flip-flop, S and R inputs. First value we have given. Okay, do a change here, put a 0 0, and then 0 1 1 0 1 1, and then again 0 0. Okay, it's up to you how you give the input values. Okay, and then we have just given the values and waited for the 20 nanoseconds. Okay, you can wait for as per your choice. Then end process, then end test data, that is the architecture. Okay, so now we'll see how this graph look like. Okay, all right, we have to just declare this, copy this entity name to here, and we want a em wave. Okay, okay, get rid of some signals that you don't want. Yeah, it's not necessary you have to cut it, but it's your choice. Okay, when S and R equal to 0 0, then and whatever with the value of the clock, is it 0 or 1, the next state will always remain in the memory state. Okay, as per this, when s equal to 0, r equal to 0, 1 0, as it got the memory state of 1 here, as it got the memory state of 1 and 0. Okay, so then memory state is not defined in this case, so this is, that's why it is getting a cross here. Okay, when clock is equal to 1, that time also uh, it is in the memory state only. Okay, from 20 to 40 nanoseconds, the value of the s and r equal to 0 and 1. But from the but from uh, which means as q should be 0 and q bar should be 1, but it's cross here because the clock is not working. When clock will get a higher edge and it will get on, which we have given in the code here, when it is 1 and clock event, that is a higher edge, only then it will work. So when we come here, it gives us the values, that is 0 and 1. When s equal to 0, r equal to 1, q equal to 0 and q bar equal to 0, equal to 1. You can just see here, when s equal to 0, r equal to 1, q equal to 0 and q bar equal to 1. Okay, like this you have from 50 to 70 nanoseconds. Wait, yeah, from 40 to 60 nanoseconds you have s equal to 1 and r equal to 0. Yeah, now when s equal to 1 and r equal to 0, s equal to 1 and r equal to 0, you should get q is equal to 1 and q bar equal to 0, but we get here q bar equal to 0 and q equal to 1. It's just the opposite because it's a memory state. When clock equal to 0, it is in the memory state, and when we will get it as 1, it will come in its sequence, that is when s equal to 0, q equal to 1, and r equal to 0, q bar equal to 0. Okay, from 60 nanosecond to 18 nanoseconds, the s and r value is always 1, and s and r is, when s and r value is 1, it's in 0 0, that is invalid state. Okay, but it is 1 and 0 because it is in the memory state. Clock is 0, that's why it is in the memory state. Okay, when clock is high, we'll get the undefined values, invalid values at s equal to 0 and r equal to 1. Okay, when from 80 to 100 nanoseconds, we have again 0 0. On 0 0, that's a memory state, and memory before this was invalid. Okay, that's why here also we are getting the invalid state only. So I'll just provide this code in your description.